Hi, Professor Bob Young here, and in this video we're going to talk about test for symmetry. Alright, so there's three tests for symmetry. Symmetry with respect to the x-axis, y-axis, and symmetry about the origin. Now notice it says here, the equation is unchanged. For x-axis symmetry, we're going to replace y with negative y to get a resulting equivalent equation or graph. Okay, for y-axis symmetry, to test it, we're going to replace x with negative x. And they've got some pictures down here of what x, y axis and origin symmetry is. And the origin symmetry test is replacing both x and y with negative x and negative y to get the same equation back. I know what some of you might do, and you might be scratching your head. So let's run through this one more time. The graph of an equation is symmetric with respect to the y-axis if the replacement of x with negative x results in an equivalent equation. The graph of an equation is symmetric with respect to the x-axis if replacement of y with negative y results in an equivalent equation. I know what some of you are still saying, but Young. So let's do one here. So it says test for symmetry with respect to the x-axis and the y-axis for this equation here. And they've got the graph over here as well. So we're going to go ahead in this problem here, and we're going to test for y-axis symmetry first. So I'm going to put y-axis sem test. So notice we're going to go ahead and take the x in this equation and replace it with negative x. Now what happens when you take negative x and square it? You get the same thing back. So notice replacing x with negative x resulted in the same equation or equivalent equation, whichever way you want to say it. So this graph has y-axis symmetry. And notice something else about a graph that has y-axis symmetry. I'm going to take some points here. It looks like the 0.15 is on this graph. Would y'all agree? Notice if it's symmetric about y, if we plot a point over here, what just happened? Well, we get negative 1,5, but what changed? X did. The sign on x changed. So see, when you replace x with negative x and you get the same resulting equation back, that's what's happening when something has the y-axis symmetry. All right, now this one, okay, we've already gone through that argument, so we've shown that. Well, let me back up here. They did not test this one for x-axis symmetry. So we're going to go ahead and take this one here, and we're going to test it for x-axis symmetry. Right? Which this graph certainly doesn't look like it reflects about x, does it? All right. But anyway, to test for that, we would replace y with negative y. All right, so that's what I did here. Now, obviously, you can tell that's not going to be the same equation back because one's positive y and one's negative. Or if you wanted to solve this for y, you could multiply both sides through by negative 1, and look what you would end up with. Are these two equivalent equations? No. So this one has failed the x-axis symmetry test. And again, something with x-axis symmetry, I'll just run through it here. Let's take the point 2, 1, which is down here. If it reflected about x, would y'all agree that I would be down here at 2, negative 1? So when you test for the x-axis, notice the signs on y change. That's why you replace y with negative y to test for x-axis symmetry. All right, now this one says go ahead and test for symmetry with respect to the x and y axis. So again, looking at the solution down here, they replaced x with negative x, so they wanted to go ahead and check again for what? Y-axis symmetry. So the y-axis symmetry test is replace x with negative x. We get a resulting equivalent equation back. Y-axis symmetry. All right, let's take the x-axis symmetry test here. And when we check that, we put in negative y for y, and it failed the test. So just to make sure you got it that time, and you can also do the happy and sad faces when this works or doesn't work. You can go, no x symmetry. All right, now let's do the test with this next equation here, x equals y squared minus 3. So we're going to first, I guess, do the x-axis test on this one. We're going to test for x-axis symmetry by replacing y with negative y in here. And notice it comes back the same. So on this one, we can do the happy face. Now, if we're going to test this for y-axis symmetry, and this one didn't even give us the graph, that's just plain mean. We'll do some more graphs if y'all want to. Y-axis symmetry test, we're going to replace what? X with negative x in this equation. And I think you're going to see that those two are not the same. Y on y. Well, one's got a positive x. When you replace it with negative, the other's got a negative x. Or again, if you wanted to solve for x and make it look like x equals, you could multiply through by -1. But no matter which way you look at this, ladies and gentlemen, you're not going to get what? An equivalent equation. And there's the graph of the picture showing that this one does have x-axis symmetry. Doesn't it look like it's kind of looking across x in the mirror there? So that's what we're after here. Now this one we're going to test for symmetry with respect to x and y. Now notice here, substituting in negative x for x and negative y for y, we get when you square something negative, no matter which way you do it, the same thing back. So this one has both x and y axis symmetry. And if you remember from previous lessons, this is our friend the circle, centered at 0, 0, with a radius of 4. And by the way, this one would also have origin symmetry if you replace both x with negative x and y with negative y. So this one would have x, y, and origin symmetry. All right, now it says test for symmetry with respect to x and y here. So let's just do one more of these. You just can't do enough examples here. So we'll do the x-axis test first. I'll say x-axis sim by replacing y with negative y. Now, do I get the same thing back? I'm going to have to go with this face on this one, ladies and gentlemen. Let's go ahead and test it. Now, don't peek down there. Don't peek down there. Y-axis symmetry test, we'll replace x with negative x. Y'all think we're going to get the same thing back here? Some equations have no symmetry. It's not symmetric about x, y, origin, nothing. Speaking of origin, we haven't done enough of these examples, so we've already talked about this, but the graph of an equation is symmetric with respect to the origin if replacement of both x with negative x and y with negative y results in an equivalent equation. So the one we did earlier that I've already mentioned with the circle, notice if you replace both y with negative y and x with negative x, you certainly do have origin symmetry. All right, let's try one more. How about this one, y equals x cubed? Is this graph symmetric with respect to the origin? Now notice here we replace both y with negative y and x with negative x to do the origin symmetry acid test. Now when we cube a negative x, we get negative x times negative x times negative x. Well, negative times negative times negative is negative x cubed. Now notice we've got minus y equals minus x cubed. Multiplying through by -1 yields the same equation back. So the origin ones are kind of real tricky. You have to be careful with those and make sure that you solve for what it was given here. This one does have OSEM. Now, did you want to test this one for the other two? Just for fun, let's go ahead and run through one more here. X-axis symmetry test. Replace y with negative y. Sorry. Or if I multiplied through by -1, not the same again. Y-axis symmetry test. Well, you have some of these on the test? Oh, yeah. Replace x with -x. And when you do that, make sure you lock in those variables when you're replacing things here. So I always like to put the parentheses when I'm putting in things. And notice I will get not an equivalent equation back because this will come out -x cubed. So it must come back the same to have the symmetries. All right, Bob Young signing off.